And welcome back. And we're on to the higher plus 5 a day, and it is the 21st of February. And let's have a look at this first question. Okay, so what do we have? So the volume of two mathematically similar. So similar is clearly the key word to this question, because similar isn't an English word, it's a maths word, meaning I can use scale factors. And then it tells me, well, let's write this down as we go. So it's length, area, volume. I may not use them all, but that's fine. And the ratio is 8 to 25, which means to get from the small one to the big one, I'll multiply by 125 over 8. Now, your teacher may be really annoying. Your teacher may have made you sit and learn all the cubes and the cube roots and all the rest of them. The reason for that is you get used to spotting the numbers. I know straight away that 125 and 8 are both cube numbers, which means I know the cube of those numbers is 5 and 2. And it also means, therefore, the square of those numbers is 25 and 4. There's no having to mess around with the calculator, and actually just being able to spot it is really helpful. Moreover, if you'd written 125 over 8, which is whatever that is, so 125 over 8, which is 15.625, you'd never recognise that number. It would still work, but it just means you can spot numbers more easily. Anyway, point is, learn your cubes will help. What does it want to do? So the surface area of the smaller solid is 24. Work out the surface of the larger. Well, I've done all the maths now, haven't I? So it's just going to be 24 times the area scale factor, which is 25 over 4, which is going to be, well, 24 over 4 is 6, and 6 times 25 is 150. So it's going to be 150 centimetres squared. First question done. Next question. It looks like I've got a couple of questions here. Let's read them through more so we know where we're going, because it might help us with either one. So a straight line passes through the points D and E, okay. Find the equation of the line perpendicular to, so we've got perpendicular, well, it's not bisector, but a perpendicular gradient. And find the shortest, this is going to be difficult. Find the shortest distance between the line passing through DE and the point F. Right, let's just do this bit by bit then. It would be helpful, and I'm going to call this L1, if we had the equation of the line L1. So L1 has gradient. Now I may not need this in fairness, but I'm going to do it anyway. L1 has gradient. Well, I'm going from 10 to 2, which is minus 8. And in that time I go from 0 to 16, which is plus 16, which means my gradient is minus a half. Which means the perpendicular gradient is going to be plus 2, because it's the negative reciprocal. I change the sign, turn it upside down. I can also write down the equation of L1 while I'm at it. So the equation of L1, because it goes through 10, so this point here is 10, I can also write down that L1 is y is equal to minus a half x plus 10. I may or may not need that, but I've got that ready anyway. Then this part over here, so find the equation of the line, so I'm now doing up here, find the equation of the line perpendicular to DE, so I know already that means that m is equal to minus a half. And passing through 0, 8. Well, this is my C value, isn't it? So actually this is pretty straightforward. So it's just going to be, and so I've written minus a half. That's the parallel gradient. The perpendicular gradient is 2. So therefore y is going to be equal to 2x minus 8. Gradient of one is minus a half, gradient of the other one is 2. I've got the C, or the intercepts. Going well so far. Then it says find the shortest distance between. Well, I'm actually going to draw a quick sketch of what's going on. So the equation of the line perpendicular to DE passing through F, which is 0 minus 8. Well, if that's 0, 10, 0, 8 here, and perpendicular is sort of like that, right? Find the shortest distance between the line passing through DE and the point F, where the point F is this bit here. Okay, this is going to be the length of the line that goes from, let's just write down 0 minus 8, and this is the point F. So basically it's saying, what is the intersection, which I'm going to call M, don't know why, let's call it M. What is the intersection point M, and what is the length M to F? So first of all, I need to find out what the intersection point is. Well, that's going to be where 2x minus 8 is equal to minus a half x plus 10. If you've seen any of my other videos, you'll know that I have a fraction. I don't like fractions, multiplying by 2, which means that 4x minus 16 equals minus x plus 20. Add x to both sides is 5x. Add 16 to both sides is 36. This is not going to be a nice number, is it? But that is fine, which means that x is equal to 36 over 5. Now I'm going to put it back into this equation here to find out the y value. So y is equal to 2 times 36 over 5, which is 72 over 5, minus 8, which is going to, I'm going to do this on my calculator so I don't get it wrong. So 72 over 5 minus 8 is equal to 32 over 5, which means, now I'm going to do this over to the right, but let's write this here. So my M value, so let's write down what the intersection point is. So my intersection point is 36.5 and 32.5. Now I need to work out, I'm going to do this over to this right bit here. So I need to work out the length from M to F. So the little square line just means the length between 2 points. So that is going to be from 36.5, 32.5 to 0 minus 8. In other words, the change in my X is going to be 36 over 5. Well, that's easy. And the change in my Y is going to be 32 over 5, which is a positive number because it's up here, plus 8 because that's below the axis. So 32 over 5 plus 8 is going to give me 72 over 5. Then what I've got is basically I've got a triangle. It doesn't actually matter which way I'm measuring my triangles, as long as I'm demonstrating. So that's going to be 36 over 5, 72 over 5. This length here using Pythagoras is going to be the square root of 36 over 5 squared plus 72 over 5 squared. So I'm going to watch your calculator usage here carefully, and that is going to give me, and I'm going to use the fraction button because frankly it's really helpful. And then I'm going to add on 72 over 5, and I'm going to square that, and that's going to give me 16.1. Now, how many decimal places? It kind of doesn't matter. As long as I'm using more than one or more than one sig fig and less than 5, as long as it's a sensible number. So 3 sig figs fine. So I'm going to say 3 significant figures. Does it say any units? It doesn't, so units, but I'll leave the units out. Question done. That's a long, difficult question, wasn't it? Okay, next question. And it is a bounds question. Now, everyone dislikes bounds. I know this, I teach this, I'm very aware of it, but it is easy marks. It is almost always the case that there are some marks for working out the upper and lower bounds. There's going to be a mark for working out whether you're doing higher and lower, and there's going to be a mark for your correct answer at the end. I've also noted that this is also a suitable degree of accuracy question. So I'm going to have to work out what I'm going to call a upper, I'm going to have to work out a lower. Well, let's write this down. So a upper, if I want the biggest value of A, I need to take the biggest value of C and divide it by the smallest value of W. And if I want A lower, well, I need to take the smallest value of C and divide that by the biggest value of W. So in other words, I'm going to need C and W, largest and smallest. Well, let's do C here. So C is 120 to 3 sig fig. So the sig fig above is 121, the sig fig below is 119, which means my range is 119.5 to 120.5. So that is my C. My W is 41.21. God, this is going to be messy, isn't it? 41.21 to 2 decimal places. So that's 41.22 and 41.20, which means that is 41.205 to 41.215. Now, to be clear, these are my uppers. I'll do them in yellow, and my lowers are in green. Don't know why I've chosen those colours, but that's fine. And then I'm just going to put it into that calculation. So A upper is going to be the biggest value of C, which is 120.5, and I'm going to divide that by the smallest value of W, which is 41.205. And my A lower is going to be my smallest value of C, 119.5. I'm going to divide that by my biggest value of W, which is 41.215. Right, calculator time. Now, I need to write, not all of them, but I need to write a lot of decimal places. So 120.5 divided by 41.205 is equal to 2.92440. Now, if I need more decimal places, I'm going to have to come back and redo that, but I think that's probably going to be enough. 119.5 divided by 41.215 is going to be 2899. So 2.899. In fact, I don't need anywhere near this many decimal places, do I? Because I can see what the answer is already. 42. Then what you're going to do is you're going to round these numbers using 1, 2, 3, 4 sig fig. So 1 sig fig, 2 sig fig, 3 sig fig. The first point in which they're different is a suitable degree of accuracy, or one less than that. So let's do that. You'll see what I'm doing. So round a upper to 1 sig fig, it's 3. Round it to 2, it's 2.9, and round to 3, it's 2.92. Round lower to 1, and it's 3. Round lower to 2, and it's 2.9. Round lower to 3, and it's 2.90, which is not equal to that. So therefore my answer is the highest number where they are the same, which is going to be 2.9. Again, go through that again. You may well get a question on that, but it's relatively easy marks in an exam. You're just doing a process. You're just working your way through, picking up those marks as you go. Right. Whew. Deep breath. Final question. Find the minimum point on the graph. Now, I'm just going to use, there's a few ways of doing it. You may have learned differentiation, but I think most of you probably are doing normal GCSE. So therefore you've learned completing the square. So that's going to be y equals x minus 11 over 2 squared minus 121 over 4. That's 11 over 2 squared. Plus 1, which is going to be the same as x minus 11 over 2 all squared minus, well, 121 plus 1 is adding 4, so that's going to be 117 over 4, which means my minimum point is going to be minus, well, it's plus, because I have to change the sign, so it's plus 11 over 2 and minus 117 over 4. And that's today done. Good mix of questions. We haven't done a bounds question. We haven't done an accuracy question. You can see I've had to go over to the right a few times, so there's been quite a bit of working out today. But if you've got all that, well done. These questions are getting slightly tougher, aren't they? Do stay with me. Come back for tomorrow's questions. Keep the practice going. You'll find the GCSE exam much easier. Really, really will. Do like and subscribe. Any comments down below, I will come back to you. Thanks all.